and all the. So anyways, using YAST with the system-backup capability, generating a tarball that has an RPM list in it, and also any files that were different with a different checksum than what the RPM originally had. But that hasn't been working in prior releases, but I do have it working in this release, but it was not working completely. In other words, the system that I had before I did the backup was not the system I had after I did the restore. So bottom line, there were some RPMs missing. When I went in to look at, if you remember yesterday, VNC Viewer was not giving me a desktop. And then when I went into YAST patterns, I saw that GNOME desktop was not loaded. And X11 was missing a lot too. So I just went into YAST, software management, patterns, selected GNOME desktop. X11 was also selected as a dependency and installed that stuff. And then in XDM, I still have the init script complaining about a restart. That looks like some sort of a noisy bug. It hadn't been doing that before. Was able to stop and start XDM and get a remote desktop. So each of you should be able to get a remote desktop now. And I kind of want to test that. Again, I want you to be able to follow me and be able to use PM chart in some way. Now, Mike, I would not be running PM chart with an SSH-X and try to run a GUI across a wide area network. Encapsulating it in VNC Viewer would be better, or even better to have PM chart on your workstation somewhere. So that all you have to do is have a network socket connection open to the machine. PCP does have a thing called PM proxy to take care of firewalls as well, so that you can get through firewalls. Again, for me, interpretation of the data is what it's about, not the tool that you use. But in particular, you can see a lot more things at once with PM chart. So I guess let me just ask, Mike, are you able to get a PM chart running to one of the Floyds?
Yeah, I've got VNC Viewer going and it's working in that.
Great. How about you, Carlos?
Yeah, I got one running with PM chart on my Windows box.
Okay.
But I wasn't sure if it didn't look right.
What didn't look right?
The chart didn't look right. So I'm going to try VNC right now.
Sure. Well, I'm not sure what you mean by the chart didn't look right. The data represented didn't seem to be the right data, or?
Yeah, I wasn't sure whether to use bar graph or stats.
Okay, well, we're going to go through that again, but the lab from yesterday also had a procedure to build it. So I'm going to do that again today.
Okay.
Besides that, so that VNC was something that I had to fix. We did have, when I flipped to the newer kernel, not all the kernel modules were installed at the time to match that kernel. So I installed the RPMs. Again, I'm getting this kernel and RPMs out of the SGI no-ship directory. So it's like on disk.inger, it's like /test/stout7. The 705 tree was cloned last week, but it's not out there easily found yet. And then latest /11sp2 x8664, and then there's an SGI-no-ship directory. And by the way, when I tried to install /11sp2 over the weekend with the vanilla ISO, I was getting drops to KDB and stuff. So the vanilla kernel is very unstable, in my opinion, on a UV right now. And we're waiting for a PTF kernel to come out. So there are several Bugzillas open with Novell to get the NMI patches into a PTF and an update kernel at some point. But the ISO media will still have a kernel that has NMI problems on it. After I ran that, after I installed those RPMs that I got with the kernel, then I ran that SGI post upgrade script, and it basically does the weak updates to make sure that things are linked together and that the modules directory is all set up correctly. I did also have another problem with this system when I was installing NumaTools or something, or maybe the NumaTools kernel module. It did downgrade rev levels on my libnuma and libcpuset. So the libnuma and the libcpuset that were in Performance Suite are probably newer rev levels, or newer software, but older rev levels from what's in SP2. So I had to intervene with the dependencies or whatever within YAS to force an install of some of the NumaTools RPMs. And I still have to watch for a typo in my elilo.conf. I think it's my typo, but I don't remember doing it. But I have that NMU watchdog instead of NMI watchdog. So I need to edit the ITSI elilo.conf, but also the ITSI sysconfig uvconfig, I added in a NMI or NMU underscore watchdog, misspelling it over the weekend. I'm pretty sure that must have been my mistake. U and I are right next to each other on the keyboard, so fat-fingered it. Okay. Having said that, I also have an issue with the debug info in order for crash to work. So I've got debug info loaded, but when you bring up crash, it's still asking for a name list and stuff. Normally it knows how to find that, but I may have to spell out the whole crash command line. And let me leave that alone for now. So I don't know how things are going. I do not intend to go 6 hours like I did yesterday. My agenda today is to start off with demo and reviewing yesterday's material. And I want to in particular get into the VM stuff. And in particular, again, the main thing is procmem info and understanding how the cached field breaks out, the buffered field, the dirty, the write back, the slab, things of that sort, and understand where did all my memory go. The other key thing that I want to play with is pushing to swap and getting to the point of the out-of-memory killer and seeing if I can actually deadlock or hang the system. And then also overcommit memory, flip overcommit memory to a 2 and see how that works and explain that a little bit more. And then just do some normal memory usage analysis and try to run programs and see what happens with memory use. In other words, make the meminfo numbers move and do something. After that, with the demo stuff, I have a swap module that is very short and a lab associated with it. And then I normally on this day try to do the lecture for file system layout, but no labs for it really. And I want to be able to look at all three systems and see what the situation is. I don't know if either of you did the swap partition lab, but remember, Mike, in your system, I grabbed that second disk for a file system. And you could still use the fourth partition on the root disk for a swap partition, for a raw swap partition if you want. So before we get started, give me some feedback. Is this constructive for you? Do you have any questions? Today is memory, basically. What particular questions or areas do you want to address today? Let's start, Mike. Do you have any issues, questions, feedback?
Yeah, I mean, I've tried to belt through the labs there, and the VM one with the kernel parameters and the setting of the kernel threads max and PID max. And it's difficult to understand quite what that section is trying to show, because almost immediately you get cannot allocate memory exhaustion, and I'm thinking that it can't be trying to do that already. That must be something wrong in the setup.
Yeah.
Now I'm figuring that what you're trying to get at there is the PID max and the threads max, and it'll stop I'm assuming because it runs out of PIDs, because they're all hogged by the sleepers. But because it ran out of memory almost immediately, I'm a little confused at what it is the point you're trying to make in that set of exercises there.
Sure. So I'll actually demonstrate that.
Yeah, okay, good.
What I'm trying to do, number one, is create a process storm. Again, this is an easy service denial attack opportunity. Because these are small memory. You know, I've only got 2 blades and 4 blades, but let's put, you know, a whole bunch of sockets, 4 racks together, and the threads-max is going to be so huge that it would be an easy opportunity to bring the system down. So what you're going to find out, though, is that the max PID is being hit before we hit threads-max. And let me demonstrate that. Also, during that process storm, the process that it's forking just does a sleep for 60 seconds. So you're going to feel the impact of the forks, but you're not going to have any load associated with these processes. They will not go onto the load level because they're not running or runnable. They're in a sleep for 60 seconds. Also, again, part of it is to show that sysctl-w does not persist across reboot. So I then have you put it in sysctl.conf and reboot and check to make sure that it worked correctly. Let me come back to that in a little bit. You also had some issues with code 4 not being compiled, it sounded like, for x86. And I want to push on that too, but any other questions or feedback right now, Mike?
No, just odds and ends in the notes. Them notes are IA64 centric. You've got 16K pages and stuff like that in there, but
yeah,
and some of it isn't obvious. You might need to clean it up to say do this as root or do this as guest, or a line that says do everything as guest unless I say explicitly otherwise.
Yeah, I do have to clean it up. Again, it was written for a 2 gig 350.
Yeah. Yeah. And that is obvious on some of them.
Yeah.
Some in the things are nowhere near what you're suggesting, kind of thing. So yes.
I agree. Let me just ask Carlos, where are you? Do you have any questions, feedback, comments?
Well, I didn't finish all of the second lab.
Sure.
But I did just email you a question about, I guess, where you catted some mem info in /syst node. Wasn't sure what you were looking for. It was asking is, you know, how do you determine if this is a NUMA machine?
If it's x86, it's NUMA. My laptop is a single CPU with 1 node. So the i386 is not a NUMA kernel, but an x86 kernel or the Itanium kernels are NUMA, even if there's just 1 node.
Okay, I think we were catting.
Yeah, system devices, node number. Right?
Yeah.
And that's what the node info command is going for. So I'm just trying to get you to find where the raw file that it's coming from is.
Okay.
So again, I want to kind of go through all this stuff today. Oops. I'm fat fingering my login here. Log into Floyd 2 for a minute. I want to take a look at what's going on with Floyd 2. just going back to Carlos's question, the fact that you have the device's system node tells you that you're NUMA. But again, you could have a system that is just one socket or one node like my laptop, and it would still be considered a NUMA kernel and still have that file there. It's just one node to the machine. Okay?
Okay.
So
most systems nowadays are NUMA.
I'm sorry?
I said most systems today are NUMA then.
That varies, but yeah, the chips nowadays, the i7 is NUMA. But again, it's the x86 kernel or the Itanium kernel are a NUMA kernel, but it might be just one node to the system.
Right.
The i386, 586 kernels are not NUMA. There's no NUMA build in them.
Okay.
Now, in our case, and this happened on ICE systems too, when we went to Nehalem, we started getting basically every socket had its own memory, and that's what we called a node for a NUMA machine. So you could have one blade, like we do with UV, one blade that has more than one node or more than one socket on it.
And that's kind of, I mean, it's to me, that's, who works on 586 and 386 machines nowadays anyway?
Yeah, I know, but again, they do have backward portability for older systems. But anyway, anything else right now?
Yeah, just sticking with that a minute. That mem info in there, when you cut each of the nodes, it's not necessarily exactly the same. I've got nodes 0 to 7, and they're all about similar, but they're not exactly the same.
Correct. There's going to be prom differences between them, stuff like that. Again, this is what I say, and if you compare it to the proc mem info, they're not going to add up perfectly either.
Well, I couldn't find anything that ever agreed with anything else, I have to say.
Yeah, I know, and I just say if they're in the ballpark, and
yeah.
Let me kind of do that as a demo, but this is where I say the books don't balance. And sometimes you got to be careful of how they're counting, 1,000 versus 1024, if it's a power of 10 or power of 2.
Yeah.
And topology and proc mem info and the per node mem info, the node info don't exactly match up, and I just live with that.
Yeah, it'd be good to have a kind of conclusion page in it. I mean, I haven't read. I'm only watching the slides as they go by, so I haven't read the printed pages. It'd be good to have a conclusion page that says because they're not all the same. The best place to get physical memory is this command or whatever. The best place to get virtual memory is this command or whatever.
Yeah.
Just kind of conclusion to a ridiculously difficult subject, this VM stuff.
I agree. And again, for me, it's just as long as they're in the ballpark. But let's kind of move to the demo at this point.
Okay, go on.
So I want to come back. First of all, I want to analyze what's going on with the systems. And then I want to take a break, and then demo the sysctl and virtual memory labs, kind of walk through them, what I'm trying to get across there. And then after that, we'll take a break and then cover swap, take a break, and then talk about file system layout. That's my plan. So I'm just going to start off. You should be able to see my desktop. Again, if I'm jumping around, stop and ask a question. I like questions. Then I know you're listening and paying attention, are actively involved. Oops. Oh. Okay, so I'm going to go to Floyd 2. That is the system that I'm using, and I created a problem on it. Besides having reinstalled it. All right, so be careful when you log in. If reverse DNS lookup isn't working right, it may take a while when you're SSHing before you even get the RSA key stuff. And also, it may take a while to get the password prompt or log in because of typically memory pressure. So let's see what I got here. I'm just going to go topology. Oh, there is a - all now. That is a new option. The prior topology would print out everything, but now it's just a short report, so I'm going to do the -all. And quality of service metrics. When I'm looking at a system, I do health of the system, quality of service, and profiling. And right now, I am subjectively feeling a quality of service metric where my interactive report performance is degraded a little bit. It's not snappy, but that's purely subjective. So here I see I'm a UV1000, Floyd 3. There, I finally got everything. That was kind of slow for me. So this system has 2 blades. The Floyds are half an IRU, 8 blades total. On these 2 blades, I got 32 CPUs. This one I disagree with. A node is a socket, not a hub or a blade like it was in Itanium, and that should really read, we've already got blades, but that could read hubs. But there's really 4 nodes on this system, not 2. And again, a node is a socket, and it's memory. There is a BIOS setting that allows you to switch it over to be in the whole blade being a node, but we don't advise that because we want memory management on a per socket basis, which means there's going to be a K-swap-D for every socket and its memory. So again, here we go. I got 125 gig showing here. Now there is a naming convention. If it did GIB, the I would indicate that it's a power of 2, but they are not marking that here. So I can't really tell, you know, what units that is actually being counted in. And like 64K is actually 65536. So these look like powers of 10 number rather than powers of 2 number. 256 is actually 262. What is it, 262.114, something like that, power of 2. Two network interfaces, 1 disk controller that's basically the 2 base I/O disk drives that are there. Then we've got our blade number and showing the hub that we got, the blade ID, and the node address space ID when it's in a NumaLink system. And again, I've got 16 CPUs, and here now we're seeing 67 gig versus up here where we had 64 gig. And I'm going to write that off as this looks like a power of 2 number, and this one does not. But I'm just thinking aloud, not trying to actually balance the book and go back and see how they counted it. But understand, you know, 1,000 versus 1024, 16K versus 16,384, 256 is actually 262.114, something like that. And then we get each of the individual CPUs. Don't really care about this stuff, but clock rate, size of the caches. And here now they are indicating that these are in powers of 2. But again, this isn't a power of 2 number. 256 is not the right number. That should be like 262. 256 is a power of 10, not a power of 2 number. So again, I'm not completely believing how the units are being counted. And I also see the I/O information. And there's my LSI driver for the base I/O disks that we have. If I do an LSCSI, there are the 2 drives that I have, SDA and SDB. And those are what are attached to this. I'm going to do a DF. So here's my root. Let me do a DF-H. So I've got a 90 gig root. I'm at 5 gig right now, 97 gig that's still available. Again, it would be useful to run a system info gather with full verbosity to get a baseline as soon as your system is put together to know where you're starting on disk space and stuff. Also, I do see that Dev does have a very, very small shared memory segment, 88K. Now, by default, Dev can take half of your physical memory. So up here, we had a 125 or 128 gig memory system, and half of that there is the 63 gig. There is a mount option to specify size equals when you mount Dev in Fstab. You can also set up a limit for the number of inodes that can be put up in Dev. And again, this is a memory resident file system, so anything I put in there will stay in memory, or if I run out of memory, it could get squeezed out to swap. So there are things that can get pushed out to swap there. My boot, and then here on my system, I put SDB1 up as Data1. And it looks like I've used 35 gig in that file system right now. Another 94 gig available, 28% of it's used. And also it looks like I'm running into problems on home. I don't like seeing a home directory that's 90-some% full. I'd have to go into DU or something like that to find the disk space. Check something here for a second. BAO. I don't know if I don't have X11 running on this right now. I'm just typing it out for you. But this is a GUI defined disk space consumption. So it allows you to dig through the file system tree in a GUI type of fashion, kind of like a DU type of thing. I'm not going to use it right now, but it would be useful to run it on home and find out where all that disk space went. The hard part is you could have one big file or lots of little files that add up. So I don't typically use BAO, BAB, so that's why I had to look it up for the spelling. It's a pretty hard spelling to remember. Any questions right now? So I had 128 gig of memory, 32 CPUs, by the way, CPU map. And unfortunately, CPU map is in Accelerate, in the Accelerate ISO. So if they don't have Accelerate, they don't have this. So here we can now see what we've got for a chip type, clock rate, things of that sort, cache size. Again, 4 sockets, and there are 16 cores or 4 sockets, 4 cores per socket. But we have hyperthreading on. Anybody want to explain to me what hyperthreading is? Anybody got any suggestions?
It's just a virtual CPU on the CPU, but on the cores, so that you end up with a number which seems to have no representation to what you've got physically.
I'm okay with all that, but I'm going to add to it. How about you, Carlos? Any comments?
No.
Okay. Not all chips have hyperthreading. The Westmere does not. What hyperthreading basically is when you have a process running on a processor, it has what's called the state. Whenever you switch a process off a CPU and put another process on, the state is saved, and then the new process's state is loaded into the processor. The state is the program counter and the internal registers. It does not include caches or TLB buffers or anything like that. The state is the program counter and all internal registers that are going to be unique to each type of chip. So every time I do a context switch, I'm taking the state to one process and saving it and then going to the state of another process. Are we okay with that? That makes sense?
Yeah.
A hyper-threaded system, you have 2 states on chip. So there are 2 sets of program counters and 2 sets of registers. But there's not enough space on the wafer to put in multiple caches and multiple TLBs, because those take up a lot of space. So basically, a hyper-threaded core means that there are 2 program counters and 2 sets of registers which do not take up a whole lot of space on the wafer. So when you context switch, you're context switching between those 2 states that are on chip, and you don't have to go to memory to save the states. Also, in a hyper-threaded situation, the 2 states or the 2 threads can exist in the instruction pipe at the same time. This allows more instructions being packed into the instruction pipe and more things happening every clock period. So if I context switch between these 2 states, I don't have to throw all the instructions away that are in the instruction pipe. And it allows me to overlap, interleave, what we used to call pipelining. It allows me to pipeline the instruction pipes better and keep these 2 threads instruction streams loaded in the instruction pipe and running. So a hyper-threaded core is basically 2 sets of program counters and 2 sets of internal registers that are on core. And a context switch, we don't have to go off core to do anything. And the 2 threads that are on those virtual CPUs are interleaved and sharing the instruction pipe without throwing away and flushing the pipe every time we switch between the threads. Does that make sense? Are you okay with that?
Yep.
Now with Westmere, they were able to, get the laser wavelength shorter, get the wafering smaller, and be able to get more on it. So instead of going to hyperthreads, they were actually able to get more cores on the wafer. Disadvantage of hyperthreading could be if it is a cache-intensive, memory-intensive application, the 2 threads are going to compete for the caches. The L1, L2, and L3 will be stepped on by each of the threads. Now, when I'm on my laptop doing web browsing, hyperthreading is great for me. But if I've got 2 threads that are working on terabyte arrays, and it's a memory-intensive situation, then those caches are going to be polluted and stepped on by each of the threads. I do have hardware counter Perfx data to show you the impact when you hit hyperthreads and when 2 hyperthreads are sharing the same CPU. We okay with that?
Yeah, sounds good.
So this thing has 16 processors, but because of hyperthreads, there's 32 virtual CPUs on it. Okay? And then here's my hub mapping, and this is where we needed to look at CPU sets to make sure, for example, these are the real and these are the virtual. And I personally don't like it. On other systems in the past, it would go physical, virtual, but now we get all the physicals and then all the virtuals, which means that if I go to Floyd 3, which is 4 blades instead of 2, the whole interleaving pattern is different. So if I'm trying to pin into this type of thing, it's going to depend upon the actual system that I'm running on in terms of how the physical and the virtuals are mapped. But PBS Pro is smart enough to give you the physicals and the virtuals as a single CPU set. And then with dplace, you're going to be placing into them. So the parens indicate the virtuals. So again, you got 2 blades, 4 CPUs per socket, so that's 2 sockets, and then the virtual CPUs for those 2 sockets. And then I don't like this, but the socket numbering is relative to the system. I'm on partition 2. So sockets 0, 1, 2, and 3 are Floyd 1, and then this is Floyd 2, 4, 5, 6, 7. And I don't like that because if I'm setting up my CPU sets, I need to convert those back into the logical within the partition. I do have a PV on that one. So if I were to want to protect and isolate things, I would break on a socket boundary, and remember, every socket has its own memory and is a node. And if I wanted a boot CPU set, I would pick all 8 of these CPUs and then share that one memory attached to that socket. And then maybe put the login on the second socket. Oops. And then leave the rest open for PBS. Now the way I did Floyd 3, Mike, is I've got the first socket, half of it is the boot CPU set, and then half of it is the login CPU set. Disadvantage is I can log into the login CPU set, suck up all the memory, and impact the boot CPU set because they're sharing the same socket's memory. But again, I only had like 4 sockets. I was trying to keep my boot CPU set and my login CPU set as small as possible, but again, they are sharing the same memory and able to step on each other in that sense. Then the last things here are just showing me the sharing of the caches. Again, this L3 cache is 1 per socket, and that is also referred to as the last level cache or uncore. I'm just going to type it in here. Uncore is another name for that cache. It's not on the core. All cores on that socket are sharing it. And then this last one is showing me the physical and the virtual. So 0 and 16 are the same core. Any questions on that? No questions. Okay, so that's a quick inventory of my system for CPUs, memory, disk. I'm not really concerned about networks or anything like that right now. Again, with the DF, I do have a NFS home and I do have a second disk that's data 1. I'm going to do a cat on /proc/mounts, and that data 1 right here is an extended 3 file system. Okay, and let's find root. Doesn't really show there. Root here is also an extended 3 file system. Right now I do not have any XFS file systems on this system for a reason. And if I cat ITSI FS tab, again here I can see that it's data 1 is an extended 3. But I always go to proc mounts. And all these commands I've been going through would come out of the system info gather report, including proc mounts to see things. Proc mounts is also showing me other things in here, other mount options. So notice that I mounted data 1 with defaults. Let's see, where was it here? I just said defaults here. But now up here, I can see what those defaults actually came out to be, how the journal is being maintained, things of that sort. We okay? So doing an analysis real quick, I'm just going to do a SAR to begin with and get a baseline. And again, this system, I didn't check my clocks. My dates are kind of mixed up here. I'm not going to change them right now because that skews all of my data that I've been collecting so far, but I should have fixed the clocks over the weekend right after the install. I'm not sure what happened here. There is a clock setting at the BIOS level. When you go into EFI device drivers, you can set the clock at the BIOS level. I haven't really checked to see what that is. At least I'm in the right year and the right day. I'm just in the wrong time and time zone. But I'm just going to live with that right now.
Isn't that a hardware clock command?
Yeah, at the BIOS level, you can set the hardware clock, yes. But what were you going to, I don't know of a command other than BIOS to set the hardware clock.
Isn't there a hardware clock command in SUSE?
Don't know it. Maybe there is.
Yeah,
but
it's clock.
HW clock? I haven't used it, so I don't know. And it might not even be loaded. I'm not sure, you know, when the system was built. So here again, I am experiencing a load impact. There it is. Okay, I haven't used that one. It's a good point.
I have a lot of systems where the base I/O RTC goes out.
Oh, let's see, -R for read. So it looks like the hardware clock, at least what it's telling me here, that the date the install got was from the hardware clock from what I'm seeing here. Okay, but I'm not going to change it right now. Anything else? I did not install Gangly on these systems. If anybody wants to install Gangly, it's very easy to do. So looking at my system, when I look at a system, I look at health of the system, quality of service, and then profiling. So health of the system, I look at CPU memory disk, file system buffer cache, interprocess communication, and then networks. And then miscellaneous things like GPUs or graphics, things of that sort. So when I'm looking at health of the system like SAR or PCP, I'm looking for resource consumption, and I am implying bottlenecks, what I call a leap of faith. So if I'm 100% CPU utilization, I can expect some CPU time types of problems. So looking at my CPUs first, it doesn't look like I'm running very much user time. This would be in your program, including DSO libraries and stuff, user space. And we got nice. This would be for things that are running under a nice value. For example, cron events. There is one called locate. I should see if I can find it here. I got to remember Yum versus I got the syntax right. There's a command called locate, and it runs find and builds a database to make it quicker than using find to find things. And that thing will run at a nice value, at low priority, and then that would show up. So when I see nices, they are often cron events, but also sites may have a batch queue that's like a low priority. Again, I am experiencing a subjective interactive slowdown here, but you got to be careful, interactive versus batch. I don't want to tune to get good interactive at the expense of the batch or whatever the bread and butter work is. This is why people don't log into database servers or NFS servers, because we want them to be just doing the main service that they're trying to provide. While that's going, so the next one is system time. This is time in the kernel, and I'm not liking this. When I'm looking at a system, I'm looking for two things basically, contention and thrashing. Contention is from too many things trying to share the same resource, and thrashing is when you're doing non-productive resource consumption. You keep doing the same thing over and over and over again. System time can indicate both contention and thrashing effects. The only way I can tell the difference between the two is by getting down to profiling tools like the Perf utility, strace, things that are going to profile event by event. So I am sitting here at a 12% system time right now. Most people have a rule of thumb. Let's see, find utils - locate. That's what I wanted. I'm going to do a zipper install find utils - locate. I just want to have this thing fired up. So this is the locate utility I talked about. Okay, now going back to this though, thrashing. Kind of a rule of thumb has always been to be 10% or a 10-to-1 type of ratio, which means a lot of people, when they see system time greater than 10%, they want to know why. So if I've got a program that runs for an hour and 6 minutes of it is non-productive or wasted, that's 10% of it, and I try to find that non-productive resource consumption by profiling it and then seeing what I can do to be more efficient in my resource usage. So again, when I'm looking at a system, health of the system, I'm saying how busy things are, how many things are trying to use them. Quality of service is when I'm actually looking at time domain and time to solution. And right now, the only quality of service metric I have is my subjective evaluation of how quickly commands are returning back to a shell. When I'm doing health of the system, it's kind of like I'm a shrink. I'm looking for behavioral type of problems. This system time could be good or it could be bad. I don't know what the system time is yet. Then I need to get into quality of service. So health of the system, I'm a shrink looking for behavioral things. quality of service, I'm like an accountant going into the records and figuring out how long are things using the resources, how long is it taking me to get my answer back. In fact, performance copilot to me is an oxymoron. There's no performance data in PCP. To me, performance data is the time domain, not how busy it is or anything like that. And PCP doesn't give anything that's in the time domain. So let me get this going here. So this 12%, I am interested in finding out what it is. What would I use to find out what it is nowadays? Perf can tell me what that system time is. And I'm going to dig into that here in a minute. I also see I/O weight. Now remember, percent I/O weight is for data I/O, not for metadata I/O. So there are particular locks that are being counted. The I/O weight is counting the IO_sched lock. And calling IO_sched were things like get request, sync page, block congestion, DIO_, NFS _weight. There are a variety of IO sched locks that get counted as IO weights. But things like waiting for an inode off of an NFS server, for example, would not get counted as IO weight. So you could have an NFS server that has a high load level, no IO weight, no CPU time, but all your processes are waiting on some sort of metadata type of event. So when I have IO weight, WChan is what's of interest to me. Nothing for steel because I'm not running any virtualization. Again, this 12% over here could have been virtualization. Let me do this again. When I have idle time, virtualization, ZenWorks, VMworks will show up as system time. When I'm out of idle time, then the guest is stealing cycles from me, and then it gets counted there. Any questions on these particular statistics? They're also in top and stuff. No questions? Let me go on. A SAR-W I'm going to go. This is for context switching. And first of all, the question would be, what's a good number, what's a bad number? I've got 112,000 context switches per second, but I don't know if that's good or bad. I don't have a baseline or a reference. And I don't know, going back to my other SAR here, whatever event I'm going through started before midnight on this system. So let's see, SAR-W on -F on bar log SA26 is from yesterday. And there we can see before this event started, my context switches were less than 1,000 on this system. So this is kind of, I'm only looking at a day's worth, not a week or a month's worth, but this gives me a reference or a baseline. And somewhere around 2040, context switches started occurring. And let me see what else is going on here. Let me just get rid of this one. At 2040, 2050, right in here, that's also when the system time started kicking up. So I had some system time before that, and I had IO wait time before that. But something changed right here. So context switching is what we were talking about, the states of the process being saved. It could be just context switching between the two virtual CPUs where the processes have two program counters, two sets of registers, and we're flipping between them. Or the context switch could be going off to memory for things. Any questions yet? I'm still on CPU. Okay, I'm going to go into /proc here. Since I'm still on CPU and I see context switches, I can look at those context switches. We're going to come back to this later in the week. The CPU scheduler at the end of the workbook talks about sched debug and sched stat. this gives me the CPU scheduler statistics. And I'm just going to do a more on sched_debug. And the back of the workbook documents as best I can what these things are. And I don't really care about a whole lot of this stuff. We'll talk about a jiffy and stuff later. But here on a particular CPU, I can see processes running, some load level information. Here's the number of context switches. This is since boot. And right after it then, I've got a list of the processes that are on that CPU and the number of context switches that they're doing. So I'm now able to see these code 5s appear to be what's driving up my context switches. And I can see a whole bunch just on this one CPU. Now CPU 1, and there again, code 5 with high context switches. I don't know of any real good tool that will visualize the sched_debug information. It'd be real nice to have something like IRIX views, the SGI Linux trace tool to actually have a GUI to this stuff, but that's never happened. So I'm able to see, of course, this is what was happening when I took a snapshot. Things can be bouncing between CPUs, but in general, this is telling me what's running on a given CPU. So I'm on CPU 2 right now. And you have a real-time and you have a completely fair share scheduler. I need to talk about the fair share scheduler later, and then the real-time. So that's going to go through the same routine for each of the CPUs. So that was the sched_debug file. Any questions? I'm done looking at CPU for the moment. There is a sar-q. I'm not done, I should say. Let's just do a sar-q. So here, process run queue. I've got 144, 155, 400 processes on the run queue, but I only had 64 CPUs. This means that processes are sharing the CPUs. Generally, you're trying to keep the run queue size less than the number of CPUs that you have. However, if these processes are not CPU or cache intensive, then you can do more. Like on my laptop, having a whole bunch of web browser things going on or something like that. If I did a PS-E, I've got 1431 processes on the system. And then my load average is in the 500 range. So again, there are things that are not in the run queue that are in the load level. And remember, the load level includes the run queue. This is running and runnable. And this is everything, including the sleeps and the kernel threads. And then this is running, runnable, waiting on data I/O, which was the I/O sched lock, including get request, sync page, block congestion. But it also includes metadata wait, which is not included over here. And metadata wait is also not in the %WIO that SAR is giving me. So I have a very, very high load average. Let me see, where was the... And 2050, let's see what happened here. Now, if you remember, the load level actually was in the 1,000 range, but the load level has been consistent the entire interval here. It was like at 2040, 2050 that we started getting the high system time, but the load level did not go up with it. And what I'm doing right now is trying to correlate things. And this is where it would be real useful to be able to plot this data. There is a tool called ISAG, I-S-A-G, that can plot this data with the Tickle GNU plot interface. And I have my own little shareware tool called SPV that can plot this data as well, but I'm not going to do that right now. Any questions yet? Let me do a sar-c. Oops, I guess it's not C anymore. -v. And here I can see directory entries used and inodes. They look, this one is growing. I can see that one growing. Let me try the V here. So starting from yesterday, directories were down in the, this is stuff that's in memory. This is in the slab. So I got 600,000 directories and 600,000 inodes that I started off with, but notice it's growing. Okay, any questions right now? So now let me try a *R. And yesterday, let's go back a day here. So I started off at 3% of my memory being used. And it just kept growing, memory used, memory free. So let's go for today now. And I'm at 79% of my memory is being used. So this is what's being used. I've got 104 gig that's used on my system. And I've got 27 gig that's still free. This is what's physical memory that's still free. And again, Mike, if I added these together, they're not going to match up perfectly. But this data is coming out of ProcMemInfo. Now I'm just going to do a *R1*5 to look at the current system here. Let me get rid of this line wrap if I can. So of that 79%, I've got 26 gig that is buffers. That was raw I/O. Raw I/O means I'm going straight into /dev. No super block, no file system, no directory, no inode references. I'm going straight into raw space. And then I've got a 76 gig cached. And again, I don't really care about this, but my reservations, what I've actually reserved with Malik, I've only reserved 5% of my memory, but I'm using 79% because of the buffers and the cached. And what else is missing from this display? I don't like *R. I would not have put these here. I would have put other things here. And what am I looking for? What's missing here? Okay, we'll come back to it. So I don't like *R. I don't like free because they don't give me the detail that I need. So I have my own little script called Vmstat. And it is basically converting MEMInfo into a SAR column type report into a delta. So it's a very simple script that I've got there. So here's my total. And again, that number is different than what we saw before. Now we're at 131. This is what's coming out of ProcMemInfo. 26 gig that's free. 471 gig that is cached. Well, wait a second. What do we got up here? That is showing cached at 76 gig. But this one is only showing it at 471 meg. Anyway, clean. So we take used, which isn't here, subtract cached and writebacks and get clean. So this is data memory that I can recover. No dirty data. I don't have any writes going on right now. 28 KB is real small. No writebacks. Process space. Again, not even a gig of process space. Mapped, which is really shemem, 62 meg. And here's the number of what I was asking to figure out. The slab. I don't know when this happened, but they've added the slab into this one here. Just like in top, they added slab. I would have preferred these things broken out in better detail, which is why I have my own little script to do this. So, My slab is 77 gig, it looks like. And then after that, I got my buffers, which is at 26 gig, and no shmem. Any questions on this right now? Let me cat/proc/mem info. So again, total 131. This is what we were just looking at with SAR and my Vmstat, 26 gig free. I got 26 gig in raw I/O. I've got 470 meg in cache, so that's real small. And again, cache clean is going to be real small, so I've got a major footprint there. Notice that most of my memory is inactive, not being used. In fact, most of this is inactive page cache. So this is inactive, not application space, but cache space. Nothing on swap. Swap is completely free. There's no swapping activity. No dirty, no write back, no process space, that's less than a gig. And then mapped. Now if you remember, cached up here was in the 76 gig range, but cached down here was in the 470 meg range. So again, the key thing here was the slab. I have a 77 gig slab on this system right now, and it is all reclaimable. Meaning when I do a trim, when I run out of memory, the first thing I'm going to do is trim the slab. After the slab, then I'm going to go for buffmem, and then I'm going to go for the inactive file cache, then the active file cache, then I'm going to swap the inactive anon, and then swap the active anon. We'll come back to that on Thursday. But whenever I run into a memory shortage situation on a per node basis, kswapd is going to pop up, and it's going to go to the slab first and try to trim it. Then buffmem, raw, then the inactive file cache, then the active file cache, then the inactive anon will get swapped, then the active anon will get swapped. We okay? Any questions? So I'm still looking at memory, and my memory footprint is rather large with over 100 gig in slab and buffmem. No NFS activity. And again, here we talk about commit limits. I'm going to come back to that later. These VMLX are useless. They're just basically the addressable address range based upon the number of bits you have for addressing. They never change. They are not anything useful. And I do not have time this week to talk about huge pages. But the purpose of a huge page is to reduce TLB misses. By default, our page size was 4 KB here. And if I'm jumping off a 4 KB page, then I'm going to take a TLB miss, go to the kernel, and get the page table entry for that virtual page. That has high overhead. SGI also added in super pages to also make it even bigger so that you can get into terabyte pages. The largest here was like a 256 meg. So SGI super pages allows even bigger page sizes for a particular application. And SGI's MPT does use super pages. And I do know sites that use huge pages quite a bit as well. Again, to reduce TLB misses. Any questions right now? Okay, well, I've looked at memory real quickly, so now I'm going to look at disk. I'm just going to do SAR-DP for disk, P for pretty, and 1-5. Let's just look at it now. Again, my font is so large. Let's see if I can get let me try it again. I need to get the font a little bit, avoid the wrapping. The wrapping is worse than the other problem. Let me go to 14 here. The hard part with disk is a very large disk farm. There's a lot to see. So here I'm looking at the system live now, but I did not get a baseline. And I see SDA. I usually go to the average. SDA is quiet. There's no activity on SDA, which was my root at this point. But SDB is busy. Number of I/O operations per second, number of I/O packets being sent by the device driver to the device. We're going to come back to this at the end of today. Looks like it's doing nothing but writes. I don't see any reads here right now. Average request size, so it looks like very small. These are in blocks, 512-byte blocks. So it looks like lots of little writes. Again, I mentioned yesterday, the more I know my workload characteristics, the more responsible my configuration decisions are. So this is telling me I'm doing lots of little writes, but I don't know if this is my bread and butter or some sort of problem going on with the system. I have not profiled or actually gotten a baseline yet. Then we get the average queue size. So things are not being queued up, and the service and waits are quite tolerable. My rule of thumb is I want these to be less than 60 or 80, and these are in microseconds. No, I'm sorry. These are in milliseconds. I'm sorry. These are in milliseconds. I have seen these get into the minutes. I've seen numbers get into the minutes, thousands of milliseconds. And then also the drive does appear to be busy, 82% busy. So if it's doing lots of little writes, but not waiting for them, the busyness must be from something else. My rule of thumb, again, I like these to be less than 60, 80 milliseconds, and I like this to be less than 30% busy. If I'm root or home, I want it less than 30. But if I am a system that's reading satellite data down and the whole purpose of the file system is to stream data to it, I would expect it to be busier. So when I see busy, my question is that productive busy or is it wasted busy? What's it doing if it's always busy? And this is where, again, I have to profile that disk drive to find out what it's doing. And we're going to get into that tomorrow. But basically, there is something called block trace. And this does not work on it worked on SLES 10 SP2, but it was broken on SLES 11 and 11 SP1, but it is working on SLES 11 SP2 now. And block trace will actually, like a par-K in IRIX, actually trace each individual IOP and give you statistics about each individual IOP. And Oracle even has something called sysctl that will plot the head movement that these IOPs are doing to the device. So there is something called sysctl that will take block trace data and plot it for you to see what your head movement looks like. So that 82%, I don't know if it's good or bad. It is a threshold alarm that says, okay, it's busy. Is that productive busy or is that inefficient, non-productive busy? And again, when I get to profiling it, as a profiler, I'm looking for inefficient, non-productive resource consumption. So again, when I'm doing my drill, health of the system, I have a shrink looking for behavioral problems. Then I try to get to the time to solution domain, quality of service metrics, which might be interactive responsiveness or batch wall clock time, whatever that is. And then the third level, I am profiling, and there I am an efficiency expert looking for non-productive resource consumption. And the fact that this is doing lots of little writes tells me that there could be non-productive resource consumption here. But I'm going to come back to these three things right here. So this is a red flag for me to say, okay, look at this drive is busy. In fact, it wrapped here. It went larger than 100. Don't worry about that. That's anomalies, edge effects, parallax. Any questions? I'm going to bring up top disk here. And the problem with SAR-D, when it's a large disk farm, is you get all the quiet idle drives. With top disk now, I can actually see things. So I don't like the fact that I get the device twice. So here again, I can see that I'm typically writing 4 kbyte writes. I'm 90% busy. I'm doing 250 write operations per second, and there's my bandwidth there, about a megabyte per second. When you want bandwidth, you need to do larger sizes. A 4 kbyte is not going to give you your bandwidth. This is what's called well-form friendly I/O. This is not well-form friendly I/O. But the common denominator numbers we'll talk about tomorrow when we get into XVM. But 4K is not very efficient. 64K or 256K are more common friendly numbers. But we need to talk about striping and stripe width to understand what's a friendly I/O request size. So I do have a drive that's busy. Any questions right now? So I just want to find out what's on that drive, fuser-uvm / that was data 1 that we were just looking at from the DF report. Now the hard part when you get into XVM, LVM is to say SDG was busy. What file system is that? Well, that's what we need to talk about today. Again, I am experiencing an interactive responsiveness slowdown here. If I were quick and stuff like that, if Crash were working, I could pop into Crash and take a look at this. There we are. And code 503 is what's running in that file system. I'll tell you right now, code 503 is a program out there called Postmark. It's a metadata-intensive application to emulate an email spam attack without the network load behind it. I can also do a PS tree. I don't know if you've ever used that one. Again, not very quick in response. Let's see if I can catch some of this stuff. Get a second window going here. See if it came back. Oh, it did come back for me. So PS tree can show me my ancestry here. And there we've got the code 503s. Okay. Looks like there's 512 of them. Gee, that sounds familiar. W. Again, slow down. My load level is in the 500 range. Okay, any questions right now? So I've identified with fuser. Also, there was the IOTOP command that's available standard in SLES 11SP2 now. It was in Red Hat, and it is something you can download from the web. Now again, I've been talking, explaining the data, but without discussion, I can walk through this data quickly, and I need to go back to where I was before because I'm almost wrapped up with my health of the system metrics. Let's see if we can catch this. IOTOP is a Python type of thing. I don't think I'm going to catch it. Again, because I'm Windows, I get this garbage stuff from PuTTY. Top. Again, I can't tell what the actual ancestry here is. It's going to be one of these SSHs, bash, view, up there. We got No. Oh, it did finally come back. So, I'm running IO top and ouch, what's this? Still there? What's that thing? Are we still here?
Yeah, still there.
So what's that? I talked about this yesterday.
The journaling, kernel journaling thread, yes.
Which tells me metadata intensive right now, which correlates to my understanding of code 5 and what I'm seeing from the other things, right? I'm going to tell you right now, that buff mem, if I tried to reboot the system, it's going to take a while. Let me bring up top. And this is a case where extended 3, extended 4 can be better than XFS because I'm in a metadata intensive environment. XFS has a fixed size for the amount of memory that can be used for the journal. Extended 3, extended 4 does not. It can use all of memory for the journal. Here again, I see K journal. Oh, also look at this, log weight. This.
So what file systems is that K-Journal D working on? That's only working on X3, X4 file systems, is it?
Correct. We'll get into XFS later. But again, my root is shipped with an extended 3. This 25 gig is the journal.
So K-Journal D must be shipped as part of the X3, X4 file system stuff and not part of a standard kernel.
It is a kernel module, I believe.
Oh, okay.
LS mod, grep, journal. Well, I guess I'm not seeing it there, but let's see, ps-ef, grep, journal. Usually there'll be a brackets on some things when they're kernel threads. Yeah, there's, so I'm not, it doesn't like, it looks like it's not a loaded kernel module, but one that's built into the kernel. Okay? Because it's not showing up here, unless I spelled it wrong. Looks okay. But keep in mind, if I shut down the system, all that journal has to be dealt with, or I'm going to have an inconsistent file system. So this is part of, and this JBD might be what's firing up that daemon as well. But I don't have an exact answer for you, Mike. Okay. We go back to top now. I'm hoping I would normally try to give you a break here, but let me finish this analysis and then we can take a break. Now, these WCHANs, there's more to it than this, but basically my system right now is metadata bound. I have a hot journal. If this were XFS, then we would see XFS log daemons. And let me get into that tomorrow and Thursday as well. So here again, I'm just looking here, 300 are running, 973 are sleeping, which is WCHAN. There's nothing stopped. Stopped is like a Control-Z or a signal that says pause. And I don't have any zombies right now. We'll get into that a little bit later. I'm still at 12% system time, a little bit of IO wait. This is interrupt handler time, and there's no interrupt handler time shown here. So I've got here 105 gig of memory that is used, and 25 gig of that is the raw IO or buffers, and I'll tell you right now, that's the journal. That's what K-Journal-D is handling. So XFS is a finite size buffers. When you mount XFS, there's some options to specify how many buffers and what size the buffers are going to be. But Extended 3 can use all the memory for this stuff. So the journal is not actually keeping up, and the buffers is just growing. If I do a shutdown, I better watch and make sure that I get a clean shutdown and that buffers gets flushed. Nothing on swap. And then here again, this cache field also includes the slab. So there's my 100 gig. I've got 100 gig of metadata activity on the system right now. Any questions? Look at all these log weights going on. One of the things I can do here, PS-O, let me do an E first, -O, CMD, WCHAN, and then I'm going to grep for code 503. And now I get the entire kernel subroutine name that they're waiting on. And if I can pick one here. So if I do a cat of /proc/PID12375/WCHAN, I can also get the entire spelling without a carriage return. So all these things are stuck on that log weight commit. And I don't want to bring up crash right now, but I could bring up crash and take a look at it more closely. But crash is not giving, it's prompting me, I need to stick in a name list and stuff. Let me get back to that later to look at the process stack trace. Now, going back to top and meminfo,
so those buffers in that top display, did we say that they're also counted inside the cache because they're from the slab?
Exactly, thank you. That's exactly where I was going. You took me exactly where I wanted to go. So in the cached field that we saw before, they've added the slab in there. Perfect question. But let me go back now. Let's first of all look at the system time. Okay? So I'm going to do a Control C here. First of all, there is a top sys from SGI. So I want to find out what that system time is. Then I want to look at the buffer and the slab more closely. And by the way, the one thing I did forget to do, but we didn't show it in meminfo, IPCS-AM. I never did go through IPC stuff, but they are all attached. And again, when I looked at proc meminfo, the shemem was real small, so I skipped over IPC. Okay, so here's all my system time, a majority of the system time. Now, D stands for delta. So we got a 2-second refresh, waiting for a refresh, waiting. The load is impacting the refresh here. I'm waiting for it to refresh. So the D would be in the refresh interval. Then this is since the process started. So this kjournal D is 100% system time, which would make sense, but all these code 503s are also in system time. So that's where my 12% system time is coming from. By the way, I didn't really look to see how they're spread across the CPUs either. Let me go into top. Remember, I may have CPU sets involved here. While we're doing that, ls/dev/CPU set. Okay, so this is user and system time added together, but I also added in the CPU number. A lot of sites will do this too, top-B for batch. then I can get the entire list instead of running PS. Because top with the -B will print the CPU it was last on. Let me do this one here. Export PS_personality. PS-L. If it's not on a CPU, it'll be an asterisk. Whereas in the top -B, it will still give the CPU. So I'm just looking here. All these things actually seem to be just on the first set of CPUs, 0, 1, 2, 3. I got 64 CPUs, but they don't seem to be spread across them right now. Here we got some other things that are off on the other CPUs. Oh, here's our flush daemon. That's going to show up as an IO8, by the way. What do you think the 816 is? That's your major minor number. So let me just see what that is. Do more on /proc/partitions. We're going to come back to this later. 816 was SDB. So the journal was for the metadata stuff, but then that flush was for the data stuff. Okay, PS-E. Oh, before I do that, okay, listen very carefully. This is dangerous, except on the UV variant kernel. SLES11 and SLES11SP1 will deadlock. Do not even try a perf top on an older release. It is finally working with the -UV kernel that I've got running, and the PTF kernel that we get from Novell, I'm going to make sure that all the patches are there so that perf top works. But it will deadlock, or even an NMI will not work. And the perf utility is a standard Linux profiling tool that's available now. Been there since SLES11, but the top portion of it has been a problem. So I'm going to bring up perf top. I do have to be careful. This other window that I've got here was Floyd 3, not Floyd 2. So perf top is a top display, but now it's giving me subroutine names. So all my system time appears to be these two routines, find, group, OR, LOV. I have no idea what that is. It's part of extended 3. And this get group description. And then we've got a lock, and we've got directory lookups. Nobody knows every subroutine in the kernel, but you can go in and grep and find out what this thing is. Okay, so there's my system time. That's the actual kernel routines that I'm spending all my system time in. Now, I'm just going to pick one of these, PS-E. And just look at one of them. So there is a perf record -P for a PID, and let me just pick 14551. I'm just randomly picking one. This will now attach to a running process and profile it and tell you, oops, I am in a bad directory. I can't write into /proc. And there is a -O, let me just call it perf file. There is a default perf.data file, but I can specify a sample file that I want. Now here's where I just kind of let it run for a little bit, and then I can break out of it. So give me a few minutes, and that looks good enough. Oh, I didn't get very much data here. I only got 371 samples. Not very much there. Having trouble breaking out of it too. Well, let's see what those, that's not a enough detail. But let me just do this again. There is nothing on there for like a time domain to say sample it for 10 seconds or sample it for a given number of samples. So perf is a standard Linux tool to tell me user time and system time and what subroutine names are in it. Again, because there's 500 these things running, these code files are spending a lot of time sleeping. And perf is only going to tell you about running in user time and running in system time. It will not tell you about waits, wchans. Okay, I'll see if that works. 700 some samples at a time. So now I'm going to do a perf report. When I use perf in batch mode, I got to turn off the terminal type. I don't like, it's meant for interactive. So just looking at that code 5, again, its main system time is this raw spinlock IRQ save, and then we've got that find group, an extended group descriptor, directory lookup, another spinlock. So this is where it's spending all of its time. And it's all system time, all kernel time. I'm not seeing any code. Oh, here's the kernel itself. So that JDB module, kernel module, was the journal. Extended 3 makeDirs. Any questions? So I'm going to do one more profiling. That was profiling that, but now if I do an strace, before I do that, by the way, let me do a touch /data1/myfile. Ouch. Huh. df-h. Data 1's got 28% full. There's plenty of memory there, or plenty of disk there. 94 gigs still. Let me try a copy /boot/splat into /data1 just to pick something. Ouch, no space left on device. Any ideas?
Is that no inodes left? Is that the same error message?
Yes. You hear that, Carlos? Okay, that system time is because of no space left on device because they're out of inodes. Which is why I had this running overnight to be able to fill up that disk drive. Okay, where were we? We were just looking at one particular process. So this time I'm going to do an strace, and I'm going to put in two little t's and a big T. And -o, I'm just going to call it an strace file. And once again, I'm just counting in my head saying, how long do I want to sample and profile this process? Now, word of warning here, strace will impact performance. And there are many times when I have a high I/O intensity application that's dominating the system, and I'm getting poor interactive response. Once I attach to it with strace, it throttles back the intensity of the I/O because the strace has to be done. And then your performance problem goes away because the I/O dominating application has now been throttled back and does not have the same I/O intensity that it had before. That's good enough. So now let me do more on strace file. And there we are. Now that the T's gave me the timestamp including fractions, but I also have over here a quality of service. This is the elapsed time, not the system time. This is the elapsed time, the wall clock time from the start of the makeDir to the end of the makeDir. Okay? So, all of that activity right now, all that system time, is thrashing on makeDirs that are failing. And because they're failing, the intensity of the makers are higher, giving me that perf top and perf subroutine names that is sitting there saying, hey, I'm trying to find space. So it's spending all this time trying to find space for the inode, but there's a limit and it's hit the limit. Does this make sense? So I got about 12% system time there, all from metadata, all the journaling, and again, we're at a inode full condition on this machine. Okay, there was one last thing we missed. So we looked at the profiling and the metadata. I know of no way to look at the buffers. On IRIX, I had buff view that would tell me what's going on there, but I have no way to know what these assets are, this 24 gig. One of the things I can do, lsof, and grep for dev, or grep for /dev, to see if anything's got that open. But I don't think we'll see a kernel thread like kjournald as an open file to a process because it's a kernel thread. So I don't know of any way of actually knowing what's in that buffers field. I just know from experience and the workload characteristics I'm doing here. So we got a lot of dev nulls here, which I don't care about. Couple of dev zeros. And again, we're not going to see code 503 or the kjournal. So that didn't help us in this case. I can't see anything that has buffmem open right now. But this thing, how do I look at this? I've got an 83 gig slab right now. How do I look at it?
That top will do it, won't it?
Slab top. And I always use S space C. I want to sort by the size, the memory footprint of the tables. And there we have it, all metadata. I got 74 gig of directory entries. And 7 gig of inodes, and then this is the page cache buffer header chain. This more than likely is the headers for the journaling, the log activity the extended 3 is doing. What do we got there? About a gig of buffer head. Basically in old Unix, the buffer header chain. This is the structures linking together the data assets themselves. It includes both buffmem and cached. And I also have one here that's kind of big, well, 240 meg, 128 byte table size, or table structures. So there's where all my memory is. And remember, that correlates going back to, I can get a response here, sar-v. And again, this is also in the slab. Any questions? Appreciate your patience. We've been going for quite a while here. Okay, I was doing things by ASCII before, but I want to bring up PM chart now. Let's see, where was it? And Carlos, we need to figure out what's going on with your PM chart, but VNC Viewer should be useful as well.
Well, it looks
okay,
a lot
so I'm
better.
going to open View. I'm just going to do it from scratch. There's my CPU. Oops. Wrong host. Let me pick deployed to. Because I want to see, I'm going to put some memory pressure on the system right now. Open view, I want swap. This is all personal preference. Open view. Oh, this time, no, instead of that, I'm going to do new chart and go to mem, util. Now, I always pick something that never changes, like page tables first. This is a complaint of mine. PM chart will not put a zero origin. So by putting in something that is real small, that kind of pins zero down in the y-axis. That's the only reason I'm doing page tables, is to get me a zero reference point. Otherwise, the perspective is lost. And again, this is all personal preference, but I'm going to go with slab next. Then I'm going to go with dirty. I'm doing it a little different from yesterday. I'm going to go with dirty. Then right back. Right back is stuff that the flush daemon is handling. Then I'm going to go NFS unstable. Then I'm going to go cache clean. And I'm doing it a little different, but now I'm going to go with buffmem. The only reason I did that is so that slab was blue and dirty was red. I'm just putting the order for ease of color. That's the only reason. Now my process space with the non-pages, and then mapped, and then free. And now I'm going to apply. Oh, before I apply, let me just go to chart and make it a stack bar. I don't know if that's what you were missing, Carlos. And let me put in a title here. Okay, let me cancel out of there. I'm going to add in open view here. Disks. Disk is IO operations, IOPS. Let me do disk bytes for transfer rate, throughput. And let me do file system for space. Now that's not a DF-I. I don't have that one. Let me get this over here. Okay, so I see I'm mostly right. It's about a megabyte per second, about 250 IOPS per second. Notice most of my memory is in the slab. But again, this is really scrunched down. So I'm going to go open view. No, I'm sorry. I want to create a tab. Let me call this one memory. And in there, I'm going to this time I'm going to open a predefined view that I had from yesterday. So I'm just going to pick the one that I saved yesterday. And that one had my memory utilization and shemem. So I still see I've only got about a megabyte of shemem. Let me add another tab here. I'm going to call this one Numalink. And with this one, I'm going to new chart, go to the UV group, find the NL, find the traffic, and I'm just picking one of them. I'm going to do it by bytes. And again, I got 2 blades, which means 2 hubs with 4 Numalink ports per hub. I missed the old IRIX O view that would give me the link, actually point-to-point links. One of the things you don't see here is where that link is going to. I go back here. Where am I? My serial console appears to be hung right now. Oh, I had a watch going for some reason. By the way, if I bring up top now, I have a stopped process. That watch is now stopped. Okay? And I can't kill it because it's stopped. When it's stopped, signals are masked. I'd have to do a kill 9. In actuality, if I want to get rid of that thing, let me do a kill-L. I really need to do a continue on it to get the kill to work. So let me just do ps-e, grep for watch. Let me do a kill on 14338, but since it is stopped, it will not see signals. It's still there, did not get killed because it's in a stop state. ps-el, grep for watch. Right there, the T. If you ever have stopped processes, you look for the T there. Now, I've already sent it a signal, but the signal is pending. So now let me do a kill-continue, which was like an 18 on that PID, 14338. And now I see it terminated. Oh, what did I do? 18. I thought 18 was the continue. It should have continued from that. But it is still sitting there waiting in a signal, waiting for a signal to run, still in a stop state. Not sure why. Well, anyway, let me do a kill-9. Problem with this is if the process has shared memory segments attached, they won't get cleaned up. There, I got it killed. Okay. Now, what I wanted to show here now, so we didn't have endpoints to these things, but I'm going to do an apply here. Cancel. I don't like to stack bar those. I like to just see them on their own. But again, there's no data there. What do I need to do? Vmstat-uv-A. And notice when this comes out, it is giving me the end-to-end point. So blade 2 port 0 is connected to blade 3.0. So you actually get the end-to-end points. So here now I can see my data starting to come in. Majority of it is way down here, but I do have 2 blades that have a high NumaLink activity. 70 megabytes per second isn't real high, but any questions? I'm just about ready for a break here. Bear with me. Appreciate your patience. Let me add another tab. This one I'm going to do Vmstat. This is something that we'll come back to on Thursday. What I'm going to try to do is trim the buffer and trim the slab while we're on break. So, new chart, mem. This time I want the Vmstat group. Oh, there's some new ones I haven't seen here. Compact. Okay. So what I'm interested in is the trim statistics. These NRs I don't care about at all because we've got them from meminfo in kbytes instead of pages. So I don't myself, there are a couple new ones in there that are of interest to me, but there's my Numa, page allocations, activates and deactivates. Let me just start picking some here. inode steals. And K-swap inode steals. K-swap steals for pages, everything. Unevictable, zone reclaim failed. That might be of interest. when I'm trying to trim, if I can't get memory on my node, there will be a reclaim fail. Let's see if that does anything. Transparent huge pages are new, but there are still bugs in that area. Slab scanned, because I'm going to do a push here. And then I did have some page steals here. Page steal DMA, this one here. And then I already had, we also have a page scan DMA, this one here. Page scan direct DMA, check that one as well. So all of these are basically related to trim, because I'm going to try to push the slab down. And let's see what we got here. So there is a cat/proc/Vmstat. And that's what I'm looking at now. And none of these are working right now, and we are not in a trim situation. Now I want to keep this application running. Let me just make a mess here. ls/data1 rm-fr on /data1/guest3. See if that does anything. Wildcards can, with the amount of metadata there, the wildcards could hit a line limit. Put that in the background. Okay, so what I'm going to do now, let me go to memory here. Let me get rid of Shemem so I can see all memory. Notice I clicked on Shemem and see the blue down here. So now I can close that chart. And again, click on slab and I can see the slab is big and BufMem is big. We okay? So, memhog. Let me just go 150 gigs, see what that does. I don't want the dots coming out on me. So I should see a non-pages start to grow here. Oops, it didn't like it. Let me get rid of the output. Cannot allocate memory. Buffer and slab are too big. There we go. Let me just get rid of that output. I'm going to fire off 2 of them. So there is my process growing. We're going to run out of memory here real quick. And now what's it going to do? Look at, we're getting BufMem trimmed here first. A little surprising to me. I was expecting the slab to get trimmed first, but BufMem is being trimmed out. Let's see what happens. Now, to me, still, memory's free, but it's still trimming the BufMem, so it's fired off a trim on BufMem, even when we don't really need it right now. So a lot of that BufMem asset was coherent. The journal had been flushed. It's just sucking up memory. Okay, so now we're growing again. My BufMem is down to the small part here. But all this metadata that's in the slab is going to be a concern. Let me fire off another one here just to push it down. I'm going to go back to live here, get rid of free. There's nothing on swap yet. I might be in a CPU set, cat/proc/CPU set, proc $$ CPU set. I am in the global, so I shouldn't be confined, but I don't, we're getting another growth now. So there was a allocation stall here. We still don't have any Vmstat information coming out either. Let me fire off another one. I'm just trying to push it. Some of them are still failing. Bring up top. So there's those mem hogs running. Now they're going to try to get to 100 gig. Here's one that's at 50 gig, or I'm sorry, there's 2 gig, 19 gig. I'm going to do a shift capital O and sort by the RSS size Q. And now I'm sorting by this size. I'm waiting for the slab to start trimming. These things are just sitting there.
So what's
It's interesting, they don't have a W-chan, but they're not really growing. I could run perf on them to look at them. My system time is quite a bit higher, by the way, and I do have more IO8 now. Let's put out of here, perf top.
But that won't get trimmed there, I'm assuming, until you get, that's VM minimum 3K bytes, isn't it?
Yeah, we're going to get to min free K bytes, exactly. Let's see what that is, actually. Anyway.
I mean, you're looking at nearly, you're 3 gig or more there in the greens, free still.
Yeah, so it's really not, it might be on a per node basis or something that's going on there. Min free K bytes isn't exactly the way it is described. There will be a lab coming up on it. But here, most of my system time is still on the spin lock. So SAR-R 1-4. So I still, like you said, have 3 gig available. sysctl-A, let's grep for min_free. So that's 135 meg that it should be protecting.
Yeah.
But I'm wishing that the slab would get trimmed down better.
Yeah.
And I'm not pushing to swap yet either. SAR-big S 1-4. Still nothing going on swap. PS-EL. Prep for memhog. So they are still showing connected. They are consuming CPU time. Top sys.
Actually, it's interesting that the min free K bytes is always so low, given that most process sizes are bigger than that.
Well, this is just breathing room for the kernel. Now, let me come back to that a little bit later. Well, that's just breathing room for the kernel. You're not going to be putting processes in there.
Oh, okay.
So that the TCP stack growth does go into there. And we have had workarounds in the past for the out-of-memory killer and increased it for the killer to prevent deadlocks by giving it more breathing room. So anyways, my memhogs are all stuck on system time. And all that system time is the malloc and the memory growth. Let's see, what else should I do here right now? But I'm not getting that slab pushed down. I'm going to do first of all, let me do date. Let me do time, BC free -F. And keep in mind, I still have these code 5s. They're trying to use the slab. Oh, so we got the buffmam cleaned completely. Now I got the problem of two colors that are the same. Let me get rid. And I am starting to drop data. I am starting to feel the memory pressure situation. So this is a bad scenario. I'm trying to push the slab down. And I'm still at an 80 gig slab. Let's take a 15-minute break here, come back at 20 minutes after the hour, and see what this does when we're back. Okay? So we'll see you 20 minutes after. Hello, are we back yet?
Yep.
So, I'm going to continue with demo a little bit. I want to get back to the labs and stuff, but I just wanted to go through a drill where I had a metadata intensive situation because it takes time to grow the slab overnight. And once that slab got there, we were, what, 60 gig in the slab or something, which is my threshold. When I did the BC free, it took 14 minutes to recover that memory. Well, we got 403, yeah, about 15 minutes total. And all that was system time in terms of the trim. Any questions at this point? By the way, I'm not seeing any Vmstat Statistics, which does surprise me. Numalink, I'm just seeing those two. Let's see what they are. There's a couple there. So there, those are the four, let's see, blade 2, blade 3, 0, 2. Those look like both the in and the out. So these are point to point. Again, we're not seeing in PM chart what this one connects to. But when we used LinkStat, we could see that it, if I remember right, it connected to blade 3, port 0. And this other one to blade 3, port 1. But I'm just guessing on that. And they do have the same behavior on top of each other. Let's see, where was it? I'm a little surprised I'm not getting any counters from any of the other statistics. That does surprise me. And it does surprise me that I'm not getting any Vmstat data. Let me check something here. I have my own little script here to put it into a curses format. Page faults, page freeze, activates.
So the data that was in the slab, which was huge at 60 gig, I mean, that comprises some of the file system stuff, but equally it comprises generic regions, 1024 byte areas, whatever. So what the data that's fine, the data that's with the file system stuff, that's all been flushed out to disk. The stuff that isn't file system stuff in there, if we have a lot of that, we end up swapping.
Once we've trimmed the slab as far as we can go, just to go back here though, this little script I have to make it easier to look at the data, and I'm not seeing any page steals or anything like that right now. I'm going to watch for this on Thursday as well, trying to make those numbers move. Now, oops, I quit out of it wrong, by the way. I broke out of it and it kept refreshing my screen. cat/proc/mem-info. So some of this is unreclaimable, but we should be able to trim the reclaim. But again, there may be points where the reclaim, there is a sysctl zone reclaim mode, and we were talking about that zone reclaim timeout. Let's see. So it may give up on the trim and then actually do start swapping. I haven't looked to see if I've got swap yet.
Oh, what's in the unreclaimable? That's dirty stuff that we've generated inside kernel threads. So that won't get swapped. Is that what that's saying?
The unreclaimable will not swap, but these are structures that cannot be trimmed. When I was on GPFS, those were all unreclaimable. I don't know the exact kernel routine that is determining whether it's reclaimable or not.
Yeah, okay.
But if there is a timeout kind of thing, we try to reclaim, zone reclaim failed, and that zone reclaim mode and how we handle some of the reclaiming, and then we might give up on the slab and then actually do get some swapping, which could include SHMEM being swapped or TempFS being swapped, not just process space. So I can't really go any deeper into your question. The slab top will tell you, what the structures are and how big they are, but I don't know of any way of knowing which ones are reclaimable and which ones are not. But I do know GPFS had a whole bunch of, it was a size-16384. So instead of using the Linux page cache, file system buffer cache, it allocated 16 KB buffers in the slab, and those were not reclaimable. But I don't know the detail of how the kernel module did that. Anything else, though? Are you back with us, Carlos? Are you okay?
Yeah, I'm here.
Okay.
So what was it that determined the level at which that stopped? Where the green ended up down, 3 ended up at its lowest level there? What, on that graph? No.
You're talking about the memory charts?
Yeah. Yes, I was.
Okay. So let's try asking the question again. It put you down as far as it could. We're going to come back to the trimming on Thursday, and there are several sysctl parameters that control this.
Yeah.
And let's see if I've got them here. So min slab ratio I increased, which allowed my slab to get big. So I said I can use 99% of my memory for the slab. Now the lowest it can go is 5%. Now since I'm trying to get big slabs to emulate what a big memory machine would have, I've just bumped this up so that I can push my slab up into the 60 gig, 100 gig range.
Yeah.
And then swappiness 100% says I'm not going to be very aggressive at trimming the cache, but I'm going to protect the cache and swap process space. But I didn't really have any process space that could get swapped. Memmapped and stuff was all I was pushing on, not malloc space. And then there's this Bfs Cash Pressure. Let's see if I can find it here.
Yeah, that's something like prefer to flush directories and inodes, isn't it?
Yeah, I'm just showing you how I would look it up. It's in the Proxys. I still prefer the way IRIX did a lot of this stuff. And then we were looking for the Bfs Cash Pressure. I believe I had mine at 10. So this is the tendency to reclaim memory used for caching of directories or inodes. So at 100, the kernel will attempt to reclaim the directories and inodes at a fair rate. Decreasing it causes the kernel to prefer to protect the directory and the inode at the expense of the cache. If it's beyond 100, the kernel will tend to prefer to reclaim directory entries and cache. So the settings that I did here were intended to allow me to get my cache big. So that 10 protected my slab. This allowed my slab to grow big. This also protected my cache. And where was I here again? Let me go back to swappiness. Was that the other one I was?
Is it to prefer to reclaim?
Yeah, it's a preference. It's not a hard rule. So if you want a kernel to swap out more processes, and thus the cache and contents increase this value. Otherwise, the kernel swap less, decrease it. So a higher number says protect the cache at the expense of the process.
Yes, and your cache pressure, low, is saying don't reclaim the inodes
well, this one is between process and cache. Bfs Cash Pressure is between cache and slab. That okay? We'll come back to that on Thursday.
Yeah, okay.
So the swappiness is not touching the slab. This is the cache, the inactive cache versus the inactive anon. So there's inactive file and inactive anon, and this is kind of balancing how quickly do we rotate the page, put it on a least recently used list, and make it deactivated. So this is balancing the active-inactive between anon and file, whereas the other one was between cache and slab. Bfs Cash Pressure was between the cache and the slab. And that's about the best I can answer it right now. Okay. So let me cat / proc /
Never any consistency to this, you know, the way they use the slab and the word cache, the page cache and the slab or slab cache when cache refers to the slab as opposed to the page. Because that Bfs pressure is actually the slab.
Bfs Cash Pressure is between the slab and the cache in the trim. But you're right, they get fuzzy between them, but in general, cache means the active-inactive file cache or page cache, which is data, not metadata. I don't disagree with what you're saying, but in general, they are separated there. Okay, so I am in the boot CPU set here now. Let me do a memhog, 100 gig, too big. Let me go 80 gig, still too big. Again, I'm in a CPU set, 60 gig, still too big. 40 gig, oh, I still can't get anything here. Let's do a node info, or n info in my case. And I'm in the log, I'm on node 0. And what do we got there? Quite a bit, 31 gig of anon right now. What is going on here? There we are, there's the anon. Let me see what we got going here. Top. So I do still have those memhogs running. This was recorded through PM Logger, but I could have done a record and actually started the recordings, but they would have been saved on my Windows system, and I didn't want to do that. Let me kill all memhog. So what I want to try to do now is, I don't want you to see this. Okay, so I'm running something else now. Notice I've got 128, 130 gig memory, but now I actually have more memory showing here than I physically have. If I click down here, BufMem is not there, mapped is there. Look at what happens here. Cache clean, same thing. Okay, I'm going to bring up top. So what do you think's happening this time? I've got code 903s running. My buffers are real small. Go ahead, what were you saying?
We're saying that util map there, the purple, is shared memory, aren't we?
It's shmem, correct. While it's attached, the shared memory will show up in both cached and in mapped.
So that's why it's showing in the cache clean, because they've all just attached, but nobody's written in it.
Well, it's been allocated, so it has been written, it has been initialized. But TempFS and the interprocess communication shmem is counted both in cached and in mapped and in the non-pages. It will get overcounted. If I take a look at my /proc/meminfo now.
There's the cache clean there as well.
Yes, it will be in cache clean.
So that's because they've only attached but not written data into the shared memory segment. Is that right?
No, it has been written. If it's cached, it's allocated, and allocated means it's been written. In this case, it's just been initialized. I think I'm just throwing random numbers into it.
But they've not written any data into it, so it's not dirty.
It's not a true file system, so it will not show up as dirty. That's correct.
Yeah.
But since it is showing here, that is an allocation, which means it's either been initialized or is, growing. It's been allocated.
10 gig.
So shared memory, and so I've got, what we got there, 9 gig. I'm going to do something else here now. This time, again, the only thing that's growing this time is cache clean. So these code 9s, they are 9 gig in size. If I actually look at them, ps-el, ref for code 9. Oh, I want EF. When I fired it up, I specified this is the size of the shared memory segment that I wanted, which is 9 gig, and then this is the ID of the shared memory segment. So they are all attached to the same shared memory segment. But they're all going to show up as 9 gig resident, but really, you've got 10 of these things, that's 90 gig, but they're really only using 9 gig, not 90 gig. And let me do an F and get to shared here, T. And you can see how much space is being shared or is shareable between them. Let me do a kill all on the just to clean up some of that other stuff there. 03. Bring up top. I also have a CP going on in here. So there was a little bit of slab growth here, but again, most of this is cache clean. Let me add in a new chart here. Mem, util. I got rid of this before just because I wanted to see the memory map better. And I'm at 30 gig of shmem right now. Let me change. I'm going to click on that, edit chart, shmem. I'm just going to put it into a stack bar to make it easier to read, though there's nothing to stack. Okay. So it looks like the cache clean has stopped growing. Oh, by the way, look at, I'm seeing a K-swap D and some flushing. So kswap-d says I am in a memory pressure situation on node 0, which is the boot CPU set and the login CPU set. Let me do an info. Again, node info is the correct command, but I've got a version that has shmem in it. And look at what's going on here. So I'm out of memory on node 0, which is why kswap-d is running, and it is mostly shmem. 30 gig there on that particular socket. Let's see, ps-e, rep for CP. Let's do an EF. We do have some fines running right now, but here's what I was doing as well. So IPCS-AM. So I've got 12 processes that are attached to this 10 gig shared memory segment. There is a -MP, for example, which will give me the PIDs. So the segment was 131075, which is what I passed in as an argument, wherever it was, right there. 31654, that's a little bit different. 31654. I don't know why there must be some character translation going on there. But here I'm able to get the PIDs, the one that created it, and the last one to attach to it. I can also get timestamp information. And I'm starting to have problems now. I need to try to do this. We're severely in trouble right now. What do you think's going on? Let's see if we can catch it before it's too late. Remember, we were out of memory in the 0 socket. There was swap allocation going on here now too. So what I was doing within the login or boot CPU set has now impacted my system.
That's because you were doing the copy to the big file in there.
But I also had shmem segments going on, this here as well.
Well, that was where you were doing the copy to the big file, wasn't it?
Yes.
Oh, and yes. No, and yes. Gotcha. They was all running at the same time, weren't they? Yes.
My shmem had sucked up everything.
Yes.
And there's no memory on that particular node now. And this is, again, why I would say that my boot CPU set should be different node than my login CPU set. But I wanted to catch this as a scenario. So I'm in trouble here now.
For thrashing.
We don't know what is happening. There's probably some swap thrash going on. kswap-d is probably trying to figure out what to do. Can I ping it? Still pings fine because you don't need the OS and you do not need memory for a ping. The card NIC itself can respond to the ping. Now, since I'm coming through SSH, I'm going to come into the login CPU set, not the boot CPU set. And let's see just what happens there.
Is it going to swap that stuff out there in that shmem?
I'm sorry, what's the question?
Is it going to go to the swap file for all that shmem stuff? Is it going to push that out to the swap file?
Yes. Yes, it will. And that's what's being squeezed out to swap is shmem.
Yes, because essentially it's anonymous pages.
Correct. So process space, including shmem, can get pushed out to swap. Now I could kill these processes, and the shmem is still out on swap.
Yeah, and we've only got 10 gig of swap on there, haven't we?
Yep.
So we're going to overrun the swap anyway.
So, I was trying to push to an killer situation. UV-con to P2. Let's see what's on the console. Oh, control right bracket S, stole it. Still no interactive response. Again, we're in the same CPU set. Oh, I got one. So let's see if I can do this. Echo $$ into /dev/CPU set /tasks. I've now put myself into a global CPU set, and I now have better response. Now the SSHD or MindGetty is still in the boot and the login CPU sets. So I am still stuck with some of the threads, some of the processes I need, SSHD and stuff, are still in a memory pressure situation, but at least I'm in a much better situation now. And there we are with Shemem. We're out of memory. We're down to 153. These are in K bytes, so 153 meg still available on that node. SAR-S, 1-5. 100% swap used. Okay, let's see what's going on down here. So I'm in a memory pressure situation, but I'm trying to get it to a out-of-memory killer situation. Let me do a D message, pipe it into tail. There, we've got an, score 1 or sacrifice child. That's a new one here. It killed an RM, which isn't a very good thing here. Let's try top. Now I'm going to go to F here, and we now have badness available here. And there's the badness, but because I'm coming in through the serial console, I've got a problem here, so let me get rid of some stuff to avoid the line wrap. I don't need nice. I don't need virtual, really. Hit that. And now let me also sort by badness. I'm going to do a Shift capital O and sort by badness. I'm surprised. I usually see badnesses that are much higher level than this, but they're all at a 38. The higher the number would get killed first. So here, my swap is all full. Let me just do this. Kill all code 903, and the script that fired it off was use Shemem. Okay, so I still see kswapd kicking in, telling me that there is a memory shortage in that particular node. I have RMs going on, so the journal is tracking that. And by the way, nowadays in file systems, just doing an ls or a find is modifying the directory access time, resulting in journaling activity. And these RMs are stuck in some sort of start this routine. Copy is still at the top of the list. So notice my swap is still full. Let's see here. Did I get logged in here? No, I didn't. Now keep in mind, when I'm trying to log in, there's not even memory for shared text, the login command, things of that sort, and the whole .initialization, .bashrcs and stuff like that all have to fight for memory to do anything. And because I'm in a memory pressure situation, I'm being squeezed in there and fighting with myself. We need to talk about mem hardwall later in the week, which is not working. This thing right here is always a 1. Even when it's set to a 0, it is behaving as a 1. Oh, I noticed on my flight as well, I only got a boot CPU set. I don't have that login CPU set. But again, I've broken myself out if I cat/proc/$$ /CPU set. I'm in the global. Okay? It'd almost be nice to have MindGetty moved into the global so that when you log in through the serial console, you have the entire system to give you memory and CPUs and stuff. Okay, let's see what's going on with top. So I'm still in a memory situation. Look at those SSHDs are running there, kswapd, quite a bit of kswapd time. Look at all the journaling time since last night. 55 hours of metadata activity going on there. I'm just looking to see what's going on here. Interrupt handler times, missed them now. There's a find going on. Here are the interrupt handler times. I need to come back to that Friday. There's proc interrupts to tell me what those interrupts are. In fact, CPU 0's got 2 minutes, 3 minutes of interrupt handler time on it. Okay, so.
But I don't, what actually is the hold up then? Because there's only 35 gig of memory used there out of 128. It's only the swap that's full up, and that won't get pulled back in until them shemems do something. So why is the login actually jammed up?
You're still in a memory pressure situation as it's trying to do trims. The fact that kswapd is running, as it's managing to keep that 153 gig free. And again, look at where the, we don't have it here. That's one thing you don't have is on a per node basis, you don't have the cached field. And this cache field includes the shemem and stuff. So, but there's shared text in there that is just not staying in memory. In fact, a lot of times you can do a BC free and then watch it reload all the shared text and DSOs right after the BC free. I'm still waiting for something to happen here. There's my CP. Again, kswapd's running. I got finds running. Those code 503s, when they're done, they're removing stuff. Notice my system time is a little bit lower. df-i. I am putting up inodes. Question?
It doesn't make any sense with that amount of free memory, does it? It's not a memory. It's not the memory that's now actually an issue. It's the fact that them processes can't run or won't run because somebody else. I mean, you can't. That's consuming only the one CPU. But why don't the S shells and that run? There's plenty of memory there now.
Again, kswapd is keeping that memory. Let's see something here. cat/proc/sysctl.
And the kswap is responsible for the swapping in and out on that node, which is the number of the kswapd.
I'm going to say kswap's just for swap outs, not for page ins, but so remember, I've got swappiness, which is going to.
So he could be stuck swapping in and out the shared memory if they're still running.
W1-5. No swap activity going on. There's no swap IO going on.
No.
Okay. One of the things I can do here now, escape, shift, KDB. I'm in KDB now. I can type in summary and then actually see the mem info. If I was deadlocked like a few minutes ago, I can come into here and notice that most of my memory is in the active and inactive anon. Again, let's see, free, that's system-wide, not on a per node basis. We do have some dirty going on here. 128 mega dirty, a little bit of write back.
It doesn't make sense with 90 gig of free memory to be stuck, does it?
But we're in a CPU set. Let me do a BTA.
Oh, right, yes, and we've only got.
So here's an example. Let's just pick one of these things. There's the CP command that's going on, and it is in a out of memory scenario here.
Okay.
So here it's this was trying to write, took a page fault, handle the page table entry, try to allocate in page cache, and here it's got to do the allocation on a per node basis. So that's saying allocate within the CPU set, and that CPU set is out of memory.
So
and one of the other things going on right now would be the out of memory killer trying to figure out what to do as well.
So that CP was running in that you've only got a boot CPU set on there?
Correct. And I logged in through my other laptop to do it. Here's one waiting on I/O.
So only the boot CPU set is out of memory, despite it showing 95 gig of free memory?
Yeah, for everything else. So when I was interactive, I broke out of the boot CPU set by echoing my current shell into dev CPU set tasks, and that gave me more memory to breathe in. So but my SSHD or my MindGetties are still stuck within that boot CPU set.
So can we see the free memory or the allocated whatever, some memory stats from the CPU set?
Not really. I can see it by node, but not by CPU set. Let me come back to some of that later. What sites will do is a memory pressure thing. Let me come back to that.
So we'd have to now find out which CPU set we was in,
yeah.
For the one that's looking for memory, find out which node that was, and then do node, get the memory info for that node.
Yes, and there's no easy way to do that. Node info was just something engineering wrote, and I got it integrated, but it doesn't have a filter capability. Now, I did have a widget, a PCP widget, to show me memory usage on a per node basis. Let me see what I got going here. So again, I'm kind of in a deadlock situation. There, I'm getting my prompt back a little bit. And info is all I have here, or node info. I just took node info and added the shmem field. So here again, like you said, there is still memory available there.
Yeah, 150 meg.
Yeah. But we still have kswapd. Keep in mind that's what kswapd is trying to keep free. And the fact in top, the fact that we have kswapd running right here shows that it's busy doing stuff. I got an hour.
Well, we know
this is trying to terminate. Look, we got 2 zombies right now from a defunct process. So this is where
actually doing any swapping, because we saw no swapping process going on.
Correct, but it's allocated and got squeezed out there, but it's not being used. Now remember, I killed those code 903s. So now they are unattached. Oh, and by the way, with IPCS, you can only see your own unless you're root. Root can see everything, but guest can only see guest. Now let me cat/proc/meminfo again. And look at my shmem now is at 31 gig.
When you showed that node info, I noticed the other nodes have dirty pages.
Yeah.
But
bringing info back up.
Yeah, the one that's really used up is at 0.
Yeah, we're not seeing any dirty data there. That's correct. And I can't see writebacks or anything. Pretty small slab. Again, it's all shmem on that particular node.
Well, all them have gone. So that's just because the processes were killed.
Correct. And they did not clean up their shared memory segments when they were done.
No. So once we do an IPC remove of that segment, we'll get all that swap back as well.
Almost. Again, how much shmem do we have here? 32 gig. IPCS was only showing 10 gig. So let's see if PM chart is running. PM chart is not working yet. PS-EL, let's grep for PMCD. Oh, PMCD got killed, it looks like. Grep. You can see why the out-of-memory killer is brain dead. kill / var log messages. Oh, I'm only seeing eventmon d killed here. By the way, this is a point where dmessage might actually have something. Let's do a dmessage. It never got to syslog. Syslog's running in a choked CPU set. Let's just see if we can get something here. And there are all kinds of out-of-memory kills that are going on we're not seeing in var log messages. Let's see if one of them was a PMCD. Oh, I don't see it there. So I don't know what happened. We had PMCD running, but I'm not seeing any evidence of it right now. Let me do a service PCP restart. But I've seen this a lot where these messages are not even getting into var log messages. Okay, ps-e, let's grep for PMCD. It's running. Echo 32486 into /dev/cpusat/tasks. And let's see if we got anything coming out now. Still not really seeing anything happening here yet. Interesting. Echo $$ into /dev/cpusat/tasks. Let me do it should inherit by child here, so let me just try a restart here as well.
Well, is it migrating? Because it has got that low memory on there as well.
Yeah, but since I put myself into global, it should be able to get memory somewhere else.
Yes, but that also includes that node 0 out of memory in that set.
Yeah, it would be. And if I am running the command on that CPU in that node, it's going to be a first touch allocation. So I could always do a dplace and move PMCD to a different CPU as well. Okay, I am getting data back now.
There we go.
Notice my swap is all used. Let me go to memory. So there's my shemem, it's at 30 gig, and again, IPCS-AM is at 9 gig. So what am I missing? You told me before. I have my own little script, clear shemem, that will go through, find any unattached shared memory segment and remove them. Sometimes we'll do this as a cron event.
So that's showing 30 gig because we had 3 processes attached that have been killed.
Not the answer.
No, didn't think so.
So if we had like 12 of them attached, and that still would have been 9 gig with a 12 here. I'm trying to get you. You know, people, when they hit the wall.
Yes, you're right.
IPCS is there, empty.
What else is in shemem?
You had it earlier. Let's bring up top.
Oh, it's copying over the big file, is it? Is that the one? Is that still running? Yeah.
For code. Oops. I don't want those.
Copy. Copy to shemem big file.
Rep CP. So here was the copy, and I'm just creating a null file in dev shemem. ls-l on /dev/shemem.
Copy dev 0. That copies zeros to that until that runs out. Yeah.
So I've got 43 gig there right now.
Yeah.
Okay. LSOF, let's grep for shemem.
Oh, that can be 50 gig, 50%, you said.
Yeah, it can be half of my memory, but I am still I might still be contained within a CPU set. But
yeah, on the CP, yeah.
Oh, so we have grep for dev shmem. And there's the CP command.
Yeah.
And it's got dev shmem big file open.
Yeah.
Okay, now the thing is that this is a first touch. And when you get into ninfo, it's going to be whatever node that CP was running on. And then when the copy is done, so I'm just going to kill the copy now. I'm just going to break out of it here.
So he's responsible for all that use there.
Yep. And it's so easy for a job or a user to just treat dev shmem like a file system, leave files behind, not scrub them, and now you've got a performance problem. And if batch comes along and tries to allocate, it's not going to check to see how much dev shmem is left behind by other people that, you know, who cleans up their file systems when they're done, right? And then the CPU scheduler puts me on that node, and I got no memory on the node. And if I don't have another node to go to or another, you know, CPU set to go to, I'm just stuck there. So is that copy done now? Let's see. Okay, copy is still showing up here. Let me just do a kill all on CP. Now, going back to the kill, code 903 does not have a signal handler. But a lot of codes will have a signal handler. There's a signal library call that says, if I get this signal, jump off to this routine to do cleanup. And if you do a normal kill, that's like a 15 that says terminate. And then the signal handler will catch that signal, jump off to a cleanup routine, remove its shared memory segments, and then terminate. But if that process got put in the background as a stop or a pause, or Control-Z, the signal handler is not active to catch the signals. The signals become pending. And then you do a kill 9, which is not masked, but not caught, and then the application does not jump to its cleanup routine and then leaves unattached shared memory segments behind. Are you following this okay, Carlos? So I still have that cache clean, and that is the copy file in dev shmem. But there's no process attached to it, so I don't see anon pages, I don't see mapped. It's only showing up in cache clean. Temp-fs is cache clean only. So let's just remove that thing. So what I'm trying to reinforce here is the slab and the shmem can be memory leaks that you got to watch for. I've cleaned up that file, and now my system is back and healthy. I still have metadata activity going on. I don't really have any system time because the RMs are not failing or anything as we're removing them. But look they are waiting on I/O. Look at the wait I/O up above. 63% wait I/O, that's a GET request. Okay, anything else right now? I'm kind of going to move on to a next experiment. By the way, when you're in those memory pressure situations, you can't even get logged in. You hit a login timeout before anything. So I'm going to echo $$ into /dev/CPU set/tasks. That's what I call the global CPU set. So that'll protect me from anything. Oh, and by the way, we missed it, but the swap got freed up as well. Everything that was out there was on swap.
Yeah, it showed up in the top.
And look at my IO8 now as it's bursting. And you can actually see the correlation here. When the yellows and the blues up here are correlating, which are the reads. So it's getting into a read situation, we're getting into IO8. And that's what the RM was doing, was reading metadata in from the file system, but it was showing up as a GET request. We got a flush going on right now too, as it's a write. Now I want to get back into IO tomorrow, or I mean tomorrow and Thursday. Anything else right now? Let me do something else now. So I wanted to get back to your question, Mike. We were talking about this, the sysctl lab. So I want to know what kernel I'm running. Again, we're using a -UV variant kernel until we have a PTF or an update kernel. The key problem with the GM/kernel is NMIs. It will drop to KDB. There are a variety of NMI types of problems in there. In fact, when I tried to install over the weekend, it kept dropping to KDB on me. If you do use that vanilla GM kernel and it drops to KDB, you can type in Go. There's a patch called useless KDB that needs to get into the Novell kernel that we are running in my UV variant kernel. Also checking the release. Again, we did that yesterday. I'm running the latest software as of last Friday. I did an update off of the Novell update server. I got the latest kernel, and I got the latest performance suite and foundation. So I deliberately this week wanted to run the bleeding edge, the latest software I could. And the build date of that kernel is March 20th. And again, it's a -UV kernel. And then I do have to warn you, it's disk activity. If I've got partitioning and I change the disk farm, then that binary SA file will not be readable. So sysctl-A shows me the current settings. So what do I got here? Threads-max, to me, being able to spawn off 2 million threads is a potential problem. I can storm the system. I call this a service denial attack opportunity. But again, ulimit-A says my individual session can fire off 1 million. That means with 2 login sessions, I can fill up the process table and everything will, basically, forks will fail, and you were getting that no memory usage, no memory available message. That's what I want to look at here. So I looked at sysctl-A, the ulimit. Oh, the other one we want to check on was the PID. So really, the largest PID is 32,768. And on large CPU systems with multiple threads per CPU, you may not have any PIDs left at all, and you have to up PID max in the first place for a large CPU system. There is a RFE to be able to bump that up on a large CPU system. So I'm never going to hit this 1 million. I'm going to hit 32,768. Also on this site that was a 2048 CPU system, they were rotating through PIDs so quickly. And then they'd be going back to low numbers, up to high, back to low, and rotating through them too quickly. So they wanted to be able to up that. There is a max limit to what you can up. SAR-Q, let's just take a look at that real quickly. And this field right here is what your plist, that's the number of processes in the process table. Running, runnable, sleeping, the number of entries for processes and threads in the process table. Okay? plist, get that on an idle system. And again, if I were to look at plist for a month and it never gets more than 10,000, why would I want 200 million as a potential high end? Just the fork storm itself will impact the system. So let's see, we had 1436. Let's do a PS-E, pipe WC-L. We're only showing 901 there because of threads. We're not counting threads. What if I do a dash capital T, M? There we are. So now it's counting the threads as well, but it's counting some kernel threads that are not directly related. So I'm in the 1800 range rather than the 1400 range. Again, we're trying to get a newer PS that will not print out kernel threads like IRIX did. So I'm just trying to adjust to this. So now, I wanted it run as guest because with guest cannot use the last slot in the process table, but root can. If I run it as root, I'm going to be in real trouble. And here, Mike, is where I mentioned make proc might need recompilation, but let's just see what happens here. So I'm going to run this mystery 1 script and see what happens. I already know max PID was like 32,768. And that's the limit that I should hit, 32,768. Now let me change myself to guest / mystery 1. So what is going on over here? We still have everything else. There's the system time, and here we are. That is the error coming back. It is not cannot allocate memory. It cannot allocate process space. It hit a limit. There's memory available. Don't misread that message there. So tried to fork 1 million because that's what my U limit was set to, but it failed at 31,709. We did not fail at 32,768 because there were other threads there already. And right now, let's see if we can catch this here. Top. Oh, I'm stuck. Cannot allocate memory. The fork is failing. Okay, let's try an strace on top. Oops. Can't even, what's going on here? That one worked. Strace top. Oh, it's working now. Here's top opening up all the threads and stuff. So what happened was my 60-second timeout. So here was PID max minus the number of threads that were running before. If I do a more on make proc .c, so here's where it's doing the fork. The return status from the fork is the PID of what it created. And all it's doing here is sleeping for 60 seconds. Let's go back over here. I still have the IO waits going on from all those RMs and stuff that are going to be running for a while. Let's kill them off just for the fun of it.
It's odd that that doesn't return E again instead of E no mem.
That will vary. So what we're talking about, man, on ERR, isn't that it? No, I want...
Oh, no, you want.
That's not the one I want either.
You want Erno, don't you?
I'm looking for the one that actually documents the messages themselves. Man, ERRNO. A little bit too much IRIX. So here is what you're talking about. The return statuses on a system call will vary depending upon the system call. And then here's what you were talking about. EA gain is what we would normally expect. I agree. That's what I would normally expect in the past on a fork failing. But we were getting E no mem. Wherever that one is. And there are numbers to these as well that we would have been able to see with the S-trace. There it is, eNoMem. But these are generic. Now let's do a man on fork. They may, instead of having thousands upon thousands of error nodes, they will reuse these things. And then on the individual system call, the return value. -1 is returned.
That's not returning eNo space. That's returning eNoMem.
So I've got an E again. So it was not able to allocate the necessary kernel structures.
Because memory's tight, which wasn't true.
The slab was the table size. We hit the limit on the table size.
Exactly. But the memory wasn't tight. That's not actually quite true, is it?
Weren't able to allocate the process table entry. And again, this is a generic meaning.
Yeah.
So I'm agreeing with what you're saying, but you can't read too much into these. So here's where it's supposed to create callers R limit, resource limit was encountered. So let's try this again now. Are we okay with this? So there was a ulimit-A. We hit max PID before. Now let me do a ulimit-N, was it? No, it's U. And let me just go 300. So now I've got a limit of 300 processes. Trying to fork 400. I should have actually had load level visible here as well. Let me file open view, load average, stick that in there. So my load average is in the 350, 400 range of these things running. Let's see if I can catch them with top. Can't see them in top because they're sleeping. Okay, they're sleeping. Let's try going to guest, user, oops. That's strange, it doesn't like the username. I thought I asked you to it and it worked through NIS, but I'm not going to worry about that right now. Oh. So it looks like it was successful. I surprised it did it this way. Currently had 904. Tried to spawn 400. The limit was at 300. Huh. I would have expected it to fail on that one. By the way, I've had classes where max threads was too small to even get to a boot. So during the boot process, you could run out of process table entries. So I used, in the lab, I used to just set it to like 300 for max thread stash max because that was appropriate for the 2 gig 350 that I was using. And then when the students started using that number on a large memory system with lots, I should say large CPU count system, they couldn't even boot, would have to go to rescue mode and then fix their sysctl.conf. Now, I'm not going to dig in this too much, but I was expecting me to hit a max proc limit, and it doesn't look like I'm doing that. ps-e grep make proc pipe wc-l. And my system is pretty unresponsive right now. I'm not even sure my terminal is good. I don't seem to be getting characters echoed back right now. ps-e-l grep make proc ps-el. There it is. I'm fat fingering too much. Let me try again a kill all on RMs. I'm going to log out, log back in here. Oh, I'm on the serial console too. So as soon as I get out of the serial console, look, my load level is dropping now.
Yeah, it just ended.
Yep. /dev CPU set /tasks just to protect that window. Here's my end user. It's almost like the limit isn't actually being hit. Okay, let's type in a *Q 1:400. So I'm at 211. Let's fire this off again. So it's going to try to fork 200 processes, and it went to 200 processes. I don't like this. I'm running as guest, I believe. Of course, let me do something else here. su-guest instead of running as root. Okay? And then let's try to fork 200 processes. This time, processes forked before it failed. This time, we got the resource temporarily unavailable. So, Mike, that one error message of eNoMem is coming back because of the max PID. Right? We okay? And look at, I went up to 300 from 200. So I was only able to spawn 100, so my limit command was working correctly there. Let's try a ulimit-HA. So that looks like a hard limit there. Is it little HA? No, it's big H. Oh, big HA. Still 100 right now. Let me exit out of here. It's 100 there right now. Let me do a ulimit-u. Let me go 60,000. And let me also set sysctl-a grep max PID. Oops. sysctl-w. And let's make this real big now. There is a limit to it. There is a PV on this. There, we were able to get it to that one. There is a maximum limit to what you can set PID max, and there is an RFE to be able to increase that. I'd have to dig into the PV to remember what the maximum PID you can get is. Okay, now let me SU to guest. ulimit-A. So I'm at 6,000 now. I actually wanted to get to, let's see what we get here with a capital H, 600,000. ulimit-U. Okay, now SU to guest. ulimit-A. So I'm at a real big one now. So let me try running this one last time here now. So here we're trying to fork off, what do we got there, 10 million processes. And there we go with our plist. Let me bring up top. You can see the system time going on up here for all these forks that are going on. But the load level is not changing because these forks are just doing a sleep. But now the contention is in the process table. I can't spawn off top because the process table is highly contended trying to fork 1 million some processes. And I believe I'm stuck within a CPU set here as well. I can see a little bit of memory going on here. Look at the page table growing because of the number of processes that I'm forking. Let's go to this one here. Page table is growing like crazy. Slab is growing like crazy for all the process table entries being made. Let's see if I can even get anything out of this. Echo $$ into /dev/CPU set/task, just to be sure. And then slab top -s space C. And there's the process table. Task structure, that's the process table. Our process table alone is over 6 gig right now. And let's do the top. And again, top is having problems because it's got to go through the /proc PIDs. And I'm firing off millions of them right now. Oh, now we started failing. Cannot allocate memory again. And we stopped just short of the U limit. Again, not counting the processes that were running before. And can I get top up? Top is still trying to run here. I'm about done with this aspect here, Mike. I'm not sure what more we wanted to do while I'm waiting for that top. Let's see. So we were hitting max PID. Again, part of the thing here is to create a high load average, but doesn't have, a high fork intensity, but does not have a load average to it. And again, that's because it sleeps for 60 seconds. And not a whole lot of performance impact, but if I need to go to the process table, if I need to go to /proc like top is doing, now I've got performance impact. And eventually mystery 1 fails. We saw 2 different types of messages, depending upon whether we hit max PID or U limit. In IRIX, by the way, there were error messages, but on Linux, there is no error message when you hit this problem. And then we were watching the load level. It does not change because these processes are not running or runnable. They're sleeping. But plist did change. Oh, there, we've got our top up. And it looks like all the zombies are gone. It looks like it's all cleaned up now. *Q 1-5. So that event is finished. Let me try a top again. Let me run this again and watch it in top. Again, there's mystery 1, but now the intensity of the forks are so high. There's 1 make proc. I'm going to hit an I. Oops, SPY input, control right bracket, S to steal. Hit an I. And again, I'm kind of locked out here now. There we go. And I didn't really check to see if I'm contained within a CPU set either. Again, we're just locked out again. Let's try, oh, this is Floyd 3, I don't want that one. SSH to Floyd By the way, another thing to watch out for. People will log into the UV as a user and then SU to root. What's wrong with that? Most users have a NFS home directory, and you've now put an NFS home directory into root's path. You really don't want root to have anything that's NFS. Otherwise, if I've got a NFS traffic, NFS congestion, I won't be able to log in as root and be able to look at anything. So your best bet is to be able to log in through the serial console and be able to get in your own CPUsat, but also do not have NFS in your path. There was what I consider a bug out there. The diagnostics, field diagnostics RPM, oh, look at this. We're getting some, don't worry about this. I'm not going to worry about that. That is a known problem. There, the forks now failed. But anyways, going back, the field diagnostics was loading MPT as a module, putting MPT into the root's path by default when you logged in as root. But the site had put MPT on a NFS mounted file system. So every time he logged in, he couldn't do anything if that NFS file system was having problems. So he had a network problem, tried to log in, but couldn't get in as root because root had an NFS path in his path and the networks weren't working. So I've got an RFE to ask that the field diagnostics not automatically add MPT into the path, because a lot of sites will put MPT onto a NFS exported file system. Does that make sense? So you want to watch your paths. Well, anyway, so there's the failure again. I'm actually not even seeing anything in top. It's so intense right now. Look, we had 663,000 that were sleeping. I don't even know if I've got anything on this window anymore. And it's a good idea to avoid using the serial console for anything. So I had one site that would do a sync, and then the sync command would hang up their login console, their serial console login, until that sync was done. It's taking 45 minutes. And they had an unusable system except for KDB. Let me see if I can catch this one last time. I'm going to, again, get myself out of the boot CPUsat. Bring up top ahead of time, do an I. Now let me try it one last time here. I'm trying to actually see zombies and stuff. So there's one make proc that's visible, but we're only seeing one make proc, one PID. And normally I'm able to see zombies and stuff too. 116. Let's do this, top-B, let's put it into a file. A lot of times when I run this experiment, I can actually see zombies happen because it takes so long to clean up the process table entry when you're done. Response available here. Just bring up top here. Again, top's got to go into /proc. That ought to be interesting, by the way. ls and /proc. Why is that so low? Because we're trying to fork off 1 million processes here. I kind of want to wrap this up. Are there any questions right now? Let me do an escape shift KDB. I'm going to break out here for a second, control right bracket Q, and this time I'm going to pipe TEE. I'm just going to call the file DAW. And now I'm going to do a summary, which is meminfo. See, how big is the slab? We got a 16 gig slab just from the process table entry, the task structure. Notice it is unreclaimable, Mike. So the task table is something that will not get trimmed or will not get swapped. Actually, none of the slab can get swapped. Slab cannot get swapped. And huge page table entries for all the processes that were forked off as well. Now keep in mind, I could have a 4096 CPU system, and then somebody could actually run an OpenMP MPI application. So I specify with MPI run to spawn up 4096 threads, and they're linked into an OpenMP application that automatically also spawns off 4096 threads. And now you've got a ton of forks and a ton of clones that are going on in the system. I'm going to do an arch KDB. And there's all the make procs that are going on. Notice they've got a Z in them. They're all zombies right now. And top isn't even able to keep up with this load right now. So we viewed the source and saw that it did a sleep for 60 seconds after it's done. It doesn't show up in load levels because it's sleeping, not running. We checked sysctl.conf and then added in a kernel threads-max. And you had to pick a decent value. If it was too small, you won't be able to boot. You'd have to go to rescue mode. And here's what we were thinking. Resource temporarily unavailable message, but we were hitting a no memory left type of message because we were hitting the plist one. So this message, if you're making notes, depended upon how the forks failed. And we were hitting task table structures and stuff like that. This experiment was originally a IRIX, and IRIX would say resource temporarily unavailable. So then I just wanted you to add threads-max into sysctl, reboot, and see that it worked. Or actually, in this case, it's not in there yet. So I wanted you to reboot. We had changed it with the -W. But that does not persist across reboot. That's why I wanted you to reboot, and after reboot, it did not change. Then we edited and added it into sysctl.conf, and then rebooted, and then carried the change. That's all that was trying to do. And then check your limit when you're running it, rerun the script, and verify that forks failed, if we could actually get to this point. But we can't even get to this point. I don't want to reboot and drop that down into, you know, a 10,000 range instead of 20 million or whatever it was. And also watching max PID. That's the one that we were hitting by default. And we were doing a little bit of watching context switches. And I missed it here, but there was also, okay, let me get out of this if I can. I kind of have to wait for all this stuff now. I can't type a go or break out of this Arch KDB yet. But there was also a number of forks available to look for fork storms. And again, these are instant values. I'm not going to do anything else here. I think we should take a little break here. Look at my LS is starting to come back, but it's still just huge. So you can see how it's an easy opportunity to attack the system. By the way, I did this accidentally once. I had a script, an environment variable at the top, so it had value equals quote, whatever value I wanted, close the quote. And after that then was a get ops and in the get ops was a usage with a quote. And what accidentally happened was I forgot to close the quote on the value, and then it picked up the next quote being the usage, and so the next thing it saw to run was the command itself. So it recursively called itself like crazy, stormed the system, and I was running as root, and I could not recover from that. In this case, I can recover because they only sleep for 60 seconds and then go away. And we got all these zombies going on right now. I'm done with this. Is there any questions right now? Let's take a break. Let's come back at the hour. Come back in like 10 minutes. And we're going to move on to the swap module. Okay?
Okay.
So we'll see you on the hour. what did I say? We're going to start at on the hour, 2 more minutes. Okay, Carlos, are you back?
Yeah, I'm back.
And Mike, you're back?
Yep.
So that ArchKDB is still going. Any questions? I want to move on. I didn't really push on very much today. We did see some happening within a CPU set context, and I'm not going to spend any time on the overcommit right now. I need to move on. But are there any questions at this point? If you're able to see my desktop, the recordings for each day are out there, and then you need this WebEx network recorder player only on Windows to actually play back these recordings. So I've got an example down here. Here's my network player. And I found out yesterday that there are a lot smaller files when you don't have the webcam going, so I might not use the webcam like I used to. But here, these are the ARF files that you can download. This is a different class, but I'm just picking one as an example. And then you're into it, and down here, you can click to get to something. You can click up here, see my webcam, see who was in the class. And then here is an actual table of contents that you can go to and click on something. And then go to that action item or that particular page or section here. Okay, so I just wanted to show you that. Chat is also visible in here. There are people that like to save these off and, like in the ICE class, use them later if they need to reference something to refresh their memory, because I've been putting out a lot of stuff for you. With that, I'm going to stop the recorder.